Hello and welcome to this episode of And So It Flows. I'm your host, Nicole Krawcke, Chief Editor of Plumbing and Mechanical Magazine. We have a very special panel discussion planned today featuring our Radiant and Hydronics All-Stars. Please join me in welcoming John Siegenthaler, Principal of Holland Patent, New York-based Appropriate Designs, Dave Yates, PM columnist and former mechanical contracting owner of FW Behler, John Barba, Director of Sales Training at Takeo Comfort Solutions, and of course, Max Rohr, Director of Marketing and Education for Caleffi Hydronic Solutions. So thank you everyone for taking the time to be with us today.
Happy to be here.
Thanks for the invite.
So our topic of discussion is obviously everything radiant and hydronics, with kind of a special focus on low temperature radiant systems, which I know Dave and John Siegenthaler, who also writes for us, has definitely covered this topic quite a bit with our publication. So my first question for all of you would be, why are low temperature radiant systems ideal? And whoever wants to start, please go ahead.
Can I jump in?
Absolutely.
Go for it.
Whenever we talk about low temperature radiant systems, I always like to find out what the other folks here would define as low temperature. Are we talking under 150, under 130 degrees, under 110? I mean, if you think of radiators in 180 to 200 degree water, well, then technically 160 degree water is low temperature, right? So what do you guys consider low temperature?
For me, it's anything under 110.
Okay.
I'd go with 120 or less.
Okay. Do I hear 130?
Yeah, anything less. I think if you can heat a room with 98 degree water, great.
Yeah.
Yeah, I've always said, when going back to our days at Wurzbo, and I know you were there, Dave, too, as well. We would design systems between the floor joists and things like that with or without plates that would be 130 to 150 degrees, and they would work very, very well. As we started getting into condensing technology, then the lower the better. And now with air-to-water heat pumps, the lower the better still. Yeah. So yeah, I think there's a wide range when you discuss low temperature, but as you lower the temperature, the benefits start to really shine.
Yeah, one of the things that really stood out for me was Richard Trethewey was a guest. Actually, he was a keynote speaker at a Comfort Tech convention. And he made the statement that for every 3 degrees that we lower the water temperature, we increase the operating efficiency by 1%. So I contacted John thinking, surely somebody's done a study on this before. And John got back to me and said, no, nobody has. And I had 3 low temperature systems that we had designed and installed for engineers. And they had very carefully tracked their energy usage both before and after. And went back and looked at their yearly energy consumption before and after, and then looked at the heating degree days to try and extrapolate some kind of a correlation between the new water temperatures and the old water temperatures. And while it wasn't exactly 3-to-1 ratio, it was pretty darn close. Mm-hmm. So that confirmed to me that the effort for us to design low temperature systems reaped a lot of benefits, both in operating efficiency and the economy of operation. But the other thing that we found was it increased the comfort level for the people. And I think that was primarily due to the fact that the systems ran almost continuously, but at a very low temperature. And so there was none of that dolphin swing, ups and downs between comfort and discomfort in their homes. So that was my experience.
Yeah, there's a couple other points too that really support low water temperatures. And these are, looking beyond just the efficiency of the heat source and everything we've said, heat pumps, mod con boilers, absolutely true. We're going to do better efficiency. One is that hydronics is a long-term value proposition. We put a hydronic system in, that distribution system hopefully will last for decades. 50 years, 100, possibly even 100 years if it's done right. So the question is, where are we, that first heat source, be it a heat pump or a mod con boiler, let's say it lasts 20 years, 25 years, what's going to be next? And whatever that is, and we may not be around to know what that is, but the bet is it's going to operate better at low water temperatures.
So
that's
Max
one.
might be, the three of us probably not. But
Max is going to be here, yeah. Nicole will probably be
yeah,
here.
there you go. Yes.
The other thing that I think really supports designing around low water temperature distribution is thermal storage. And going forward, we're going to see utilities being more creative with utility rates, time of use rates. So devices like air-to-water heat pumps, geothermal water-to-water heat pumps, electric boilers, even elements in a storage tank, they're going to operate at low utility rate times, and they're going to increase in temperature as they take on energy. The question is, how low can we drain that tank before we have to go to some other heat source? In other words, how long can we maintain the energy flow to our distribution system based on energy we bought at low temperature or low cost? And the lower the distribution system temperature can be, the longer you can pull energy from that tank. And that means less time where you have to perhaps purchase on-peak electricity or go to some other fuel. So all those reasons kind of come together. They all gel around low water temperatures.
I think you make a good point, John, as we kind of speed or stumble down the path of beneficial electrification. Again, that just matches up with low temperature delivery in such a natural and common sense way. And again, yeah, buffer tanks with heat pumps, absolutely critical. Keep that, heat the house with the buffer tank, and then use the heat pump to recharge the buffer tank.
The past president, ASHRAE president Ginger Scoggins has a quote that I love, that's the cleanest energy is energy unused. And I think that's what Radiant can deliver here. So that's the key. The low temperature, high surface area hits those temperature and energy efficiency benchmarks without being locked to a specific energy source, like John's mentioning. That there may be some technology, some suitcase-sized fusion boiler in the future that would be amazing, some sort of Back to the Future type energy source that you put your organic compost into that's going to heat water. Great. Then we can still use the same network effects that we have in the concrete today, and it's going to work and it's going to deliver there. So it's adaptable, it's flexible, it's sustainable, and that is what I think is fun about it.
1.21 gigawatts. That's what we need.
Yeah.
So moving on. So what would you guys say are the key factors in determining the optimal design for a low temperature radiant heating system?
I went simple. I'm sorry, guys, if I jumped in, but you find the surface temperature you need to deliver the BTUs under design conditions and work your way backwards from there. I mean, that's just math. There's no, ideal water temperature. It's what's the installation method for the radiant system going into the structure. It's going to be your water temperature is going to be different if you're between the joists or in a thin pour slab or a structural slab. And then find the surface temperature you need to heat it, the floor surface temperature, and then work backwards from there.
Yeah, and for me, that always started with the heat loss in a radiant design program, and then the various methods that could be used for the installation of the radiant itself, with each one having a different temperature range that was required, and then look for whichever one's going to, deliver that lowest temperature possible. And in many cases, we found that, the other part is to draw together all the balance of system components, which is where the artwork really comes into play, and where the designer and installer's knowledge can really shine at the end of the day.
That's a good point.
It would be possible to heat a building with 85, even 80-degree water. You can get temperatures very low if the building envelope has really low heat loss, to Dave's point. Now, I want to throw a caution out, and it's not a technical caution, it's more of a marketing caution. We've looked at using radiant floor heating in very low load building envelopes where the design heat load, it can be down in the range of 10 BTUs per hour per square foot, or even a little bit less than that at design load. And what will happen is the floor surface temperatures go down as the load goes down.
Yep.
And one of the things that the radiant industry has done for decades is promote what I call the barefoot friendly floor. With the expectation from consumers that when I purchase floor heating, I'm going to walk around barefoot, but it's going to be nice and toasty and everything's great. And that definitely was the case when we had loads in the range of maybe 30, 35 BTUs per square foot per hour. But as building codes have tightened up the thermal envelopes, these loads have gone down substantially, down to maybe a third of what they were when some of us older gray-haired people got involved with radiant heating. And the caution that I would put out there is, yes, you can do floor heating in a very low load building. Make sure that you explain to your customer that the building's going to heat fine, the heat source efficiency is going to be excellent, but you may not perceive that floor as being as warm as it might have been in another building you were in perhaps last year that had 3 times the heating load. So technically everything's going to work, but make sure they understand the floor is not going to be cold. It's going to be slightly warmer, 3-4 degrees warmer than the air temperature. But when somebody has this very large expectation of, very warm floors in that type of a building, it's just not going to happen. There are a couple things you can do around that. You could limit the area of the floor heating to just where people are more likely to be barefooted, maybe in a kitchen and a tile floor, a bathroom, that type of thing. You could also go over to panel radiators, and operate them a little bit higher temperature, maybe 110, something in that range. That's going to give them some radiant output. And I've got a grandchild that loves to come in from playing in the snow and put their feet up on a panel radiator. So it's just a caution that, yes, floor heating will work. Just make sure that you explain the floors are not going to be as warm as they would be in a much higher load situation.
Yeah, John brings up a really excellent point, and that is the communication between the designer, installer, contractor, and it's critical that you deal directly with the homeowners. And I don't mean that you bypass the builder or any of the other contractors. In fact, you need to bring everybody into that communication envelope so that everybody understands exactly what's going to happen, when it's going to happen, and how it's going to work.
Yeah, I have a contractor friend, Pete Cassidy with Par Mechanical, and he does big houses in the Telluride, Colorado area. He doesn't bid jobs that he can't talk to the homeowner. If it's just some sort of, bank that you're talking to, the expression that I use, if you're trying to build a truck for like a fleet manager, you'd never have heated seats. If you're building a truck for the drivers of that fleet that are going to get in that truck at 5 a.m. and go to work, they would pay for those heated seats. They'd love to have that comfort. So if you're not talking to the customer, it's an easy, value engineer. If there's value in that, that happens sometimes, that you would just go with the cheapest way to get, hot air into a space, if that's what you're shooting for. If those are the goalposts or, whatever sports analogy you want to use, you're not going to hit it for the occupants in that case.
Yeah, I seem to remember an old radiant heating company that I used to be associated with that had big foot with a smiling toe on it, and it would say warm friendly floors, and that was probably that kind of led us down that path. In our classes, when we talk about radiant, I like to ask our groups, when we talk about floor surface temperature, what's the easiest way to increase the surface temperature of a radiant floor heating system? And I'm sure you guys know the answer, but what is the easiest way to make the floor warmer?
Turn up the water temperature.
There's one, Max.
Easiest way to increase the temperature of the floor, or
make easiest way to make the floor warmer.
I'm with John that I think the easiest way is just going to be turning up the temperature of the supply. But I know you're smiling. I know you've got a.
I got a wise guy answer. Dave?
Okay, well, I'm going with the same answer. Turn up the water temperature.
Turn up the thermostat.
Okay. Same water. Yeah. More,
turn up the thermostat. Change the heat load, right?
Yep.
Yeah.
Change the heat load. Open the window. Hell, that'll work too.
So, John Siegenthaler, you had previously mentioned the term, how radiant floor heating can be broadly interpreted, such as, stapling PEX to the underside of a subfloor without heat transfer plates, or stapling tubing to the side of floor joints. Why are these both really bad ideas?
They're bad ideas because the heat transfer from the water in the tube to the space you're trying to heat is very, very impeded. You're not creating a good, what I'll call heat transfer geometry. I think the term radiant tubing is kind of misleading. It's plastic pipe, and there's nothing magical about that tube that is going to somehow go around the laws of heat transfer. We use the term, we call it a system where the tubing is just stapled to the underside of the floor without plates, perhaps without any significant insulation, or if it's stapled to the side of the floor joist, we call that a thermally constipated system. We can put all the heat we want in the tube, but we've got a very, very impeded path for that heat to try to make it into the space. I have been to Europe several times. I've looked at different approaches they use. I have never seen that done in Europe. I'm not sure where it came from over here. The idea that, you can just leave the plates out, staple the tube to the side of the floor joist. It's a bad idea. We kind of kid around if you want to save costs. Yeah, you can leave the plates out. Well, my training was actually in aeronautical engineering, and I said, if you want to save cost in building airplanes, you just leave the left wing off. Saves costs. Doesn't fly very well, but it does save cost.
Yeah.
Or we can use a better installation method and give that constipated system an enema. Get that heat right out and it'll deliver.
There you go.
Good little
I'm with you,
thermix slacks
Dave.
right there, Dave.
Right.
Enema plates, thermal enema plates.
My experience back in our old Lupin or Worsbo days was that any folks would try to find as many different possible ways to make the system cheaper as you could think of. I mean, and it was in the pejorative use of the word cheaper and making it less, not just making it less expensive and performing. It was just, let's make it cheaper. I don't really care if it works, or why won't it work? It's still in there. And it's like you said, leaving the left wing off of a plane is kind of the perfect analogy. You can do anything cheaper. If you really want cheap, a can of gasoline and a match will heat a house pretty damn well.
And
I think there's a conversation too about the stapling up under the floor versus all of the different types of dry panel systems that go above the floor that are going to be lower mass than what we all think of when we think of an old radiant system that's at the bottom of 12 inches of concrete or something like that. That can be a great use case, especially if there's some sort of occupant request that it reacts a little bit quicker. Like John, you've talked about, okay, nobody's in this part of the church for most of the week, but then we have a bunch of people that are come in at one time. That's very different than an aircraft hangar or something that we did a military base in a former position of mine that they kind of needed to have people in there all the time. And at some point the door is going to open and they're going to move the helicopter out, but that floor is warm forever to the end of time. Versus some other use cases where like a hot yoga studio is a very different application than a boardroom where everybody's wearing a suit or something like that. Those things are changing. I think that's helpful in this scope of low temperature radiant. Is a dry panel system better than at the bottom of concrete, or hopefully in the middle of the concrete or towards the top? Those are some things to look at and not think of radiant just as the oldest kind of version that we've had in North America.
Okay. Now, there are other, ways to radiant heat a space. And John, you also brought this up, how many installers are using low temperature radiant wall or ceiling panels? And how can these products increase the versatility of radiant systems?
My guess would be that upwards of 90% of hydronic radiant panels are floor systems. It might even be upwards of 95%. We've talked about and actually done training on radiant walls, radiant ceilings. We've done articles and columns and in PM on this. I look at it as another tool in your toolbox. You may have a client that simply wants thick hardwood floors, or they have a building that already has hardwood floors. And, the idea of radiant floor heating it's going to be a challenge if it can even be done because of the resistance of the floor coverings or the layers of flooring that are already in place. So radiant ceilings, radiant walls, you can build them quite easily with the same materials that you would use in a dry panel system for floor heating. And they respond fast. They operate at low water temperatures. So again, they're compatible with heat pumps, with Micon boilers. And, when's the last time you saw shag carpet on a ceiling? Meaning that, there was a time, right, Dave and John, there was a time probably.
I had a van. Well, never mind.
It was probably avocado
say the same
color,
thing, John.
But anyway, my point is you may do floor heating and somebody buys the house 10 years later and they don't like tile. They want carpet and pad on the floor. That's a major issue. Whereas a ceiling, it's unlikely that they're going to remodel the ceiling with materials that would impede that heat transfer. And there's some niche applications for it too. We've done radiant walls inside walk-in showers with with cement board tile over it. We've done radiant ceilings in Cape Cod style, where you've got a small flat area up at the top, perfect for something like that. We've wrapped stairs, the railing system, a solid wall railing around the stairs, perfect application for radiant walls. With radiant walls, you want to be careful that where you site them, that somebody is going to push an entertainment center up against it or a big, sofa. It's got to face into a space so it can emit the heat properly. But there's no limitation on using radiant walls, radiant ceilings in combination with floor heating. It doesn't have to be all one system. So you can go into a project perhaps with floor heating in certain areas where it makes sense, and then maybe do a couple zones with ceilings or walls where floor heating doesn't make sense.
One of the most unusual projects that we got involved with that dealt with using the walls was a concrete bunker made out of pre-stressed concrete beams, where we put the radiant tubing into the concrete beams before they poured the concrete. And then afterwards, the beams were brought in with a crane and stacked on top of each other. And we had a 1 foot by 1 foot space to interconnect the tubing between each beam that was placed. And the floor itself was 3 feet thick concrete, and we had radiant tubing in that as well. What they were doing was heating up the aggregate that was going to be conveyed into the building and put into the pre-stressed concrete mix. And that aggregate has to be heated to go into that mix. It's absolutely critical for the pre-stressed concrete beams. That was a really fun project, except for the fact that it was 6 degrees out when we were installing the tubing. But other than that, it was great.
And it was a concrete bunker. What do these people know, Dave? I
don't know. We had some other really fun projects. One was a gentleman and his wife bought the top of Jack's Mountain, which is right next to Camp David. And that's where Jack Kennedy used to go for walks. So they built themselves an 18,000 square foot edifice on the top of this mountain. And one of the rooms had a huge chunk of granite that came up out of the floor. And they wanted to have a waterfall. So we built a waterfall for them. But that meant that we did not have nearly enough floor space for the walls of windows that they were going to have. So we were able to use the ceiling and the walls to make up for the heat loss. And then the other thing they had was one of those endless pools in the basement. We'd never installed one of those before, but they had us do that as well. And that took up enough floor space that we needed to use the walls and the ceilings for the radiant heat in that area. And we also put in some hydronic towel warmers as well. So there's all kinds of creative ways to deliver the comfort that people want.
Yeah, think of that, just making the radiator bigger. If the floor space you have available can't get it done, just make the radiator bigger. Well, along those lines, my dad used to do a ton of radiant heating back in the 50s. When it wasn't an unusual thing to do. And I remember he showed me some pictures of a job he did. And I'm looking at the tubing pattern, And I'm looking at a piece of paper like this, and I said, it was a picture, and I said, "Oh, that's pretty cool. I get that pattern. I understand the layout. That's in the floor, just like we're doing now." And he kind of looked at me like he had that look, and I recognized it as we got the wrong baby at the hospital. I know we did, as he grabbed the picture out of my hand and said, turned it like that. He said, "I was radiant ceiling, you doofus." And anyway, I know the look from my dad, and I give it to my kids all the time. But yeah, it's the same thing, only different. It's just coming at you from the other direction. But you guys know this? What's the one comment people who don't quite get it will always say about a drawback to radiant sealing is it doesn't work because
hot air rises.
well, they'll say heat rises, right?
Yeah, heat rises. Yeah,
heat rises, and it doesn't.
I think we've seen that look in your classes, John.
What, the doofus look, or I got the wrong baby? Yes, exactly. Thank you, Dave.
No, I mean the look that you give to the students.
Oh no, I'm usually the receiver of that look.
So, Dave, can you tell us about the relationship between water temperature and condensing equipment and why the condensing equipment lends support for designing systems with lower temperatures?
The lower, the better. The lower we go with the water temperatures, the more we condense. The more we condense, the higher the efficiency of the boiler. And, coincidentally, the better the comfort for the people upstairs and in the living areas. At least that's been my experience. And we experienced that in our own home as well. When we went to ECM circulators from the old on-off type circulators and with induction motors, we went from intermittent circulation to near constant circulation. And we also were able to bring the water temperature down because of some other changes that we made. But my family, who have always been my guinea pigs for research, oftentimes I never told them what I was doing down in the mechanical room. And I just simply made changes and then waited to hear compliments or complaints. And normally it was compliments. And after I lowered the water temperature and went to near constant circulation, both my son Michael and my wife Lois remarked a couple of weeks later, "Why are we so much more comfortable now than we were before?" And that was exactly why. And I've had the same experience with my customers where we're able to do the same thing. So lower water temperature means more condensation. And the one thing we really need to do as contractors is treat that condensate because of how acidic it is. And make sure, especially if there's cast iron drainage under the floor or in the walls, we want to make sure that we treat that before it gets into the cast iron drainage system so it doesn't ruin it. And the same thing if it goes across a concrete floor, it'll quickly etch the concrete floor. So Mrs. Jones isn't going to be too happy if we're going to ruin her basement floor. And of course, the other thing is the shortcut of simply drilling a hole in the concrete floor and sticking the condensate drain down into the stone area underneath the floor is not good. So properly treating the condensate and pumping it away if need be to a drain is absolutely essential. But yeah, you guys can, echo that. The lower the water temperature, the better.
That's the marketing issue that we have, is that if we do everything perfectly and somebody moves into the building, they don't even know what the heating system is or where it is or how it works, that it just is invisibly comfortable. If a homeowner knows a lot about their heating system, they're probably not happy about it. They don't really want to spend the time in the mechanical room figuring out, why is the house cold? Why isn't this working? Why is this zone cold? If they don't know anything but the name of the thermostat on the wall, that's probably a good thing. We're probably delivering comfort really well there. And then if they aren't shocked by the heating bill, even better. So we don't really, the marketing issue we have, we don't really want the customers down there picking around in the mechanical room, unless they're just marveling at how great the system that Dave installed looks or something like that. We want to just deliver the expectations without the fuss and the noise and the dust and things like that.
Max brings up a great point, and that is you have a change in homeowners, and the new homeowners come in and they like Persian rugs, and they throw these beautiful Persian rugs down across the floor. And so now your ultra low water temperature system isn't making them comfortable when it's 0 degrees outside. But the other advantage of having a low water temperature system is there's a tremendous amount of flexibility that we have in the ability to raise the water temperatures and overcome those problems and restore comfort.
Yeah, always leave yourself a little leeway when you design. Yeah,
Yeah.
it's like something change, because people always ask us, what if something changes? And I says, well, that's why you don't design to the limit. You have some flexibility.
Yeah.
Now, you guys all kind of touched on, some alternative heat sources earlier, but what are the benefits of using, low temperature radiant heating in combination with things like geothermal, water to water heat pumps, and air to water heat pumps?
Well, it's beneficial electrification's coming. I mean, there are places now that you cannot put in a fossil fuel boiler. They it's just not an option. They've been regulated out of existence in new construction. You can't get a permit if you have fossil fuel. So you're kind of left with those alternatives. So if that's your alternative and you're not going to get anything more than 120-degree water, well, you sure as heck can't design for anything more than 120-degree water. It's just at that point, it's a matter of survival.
And with geothermal, if you have a low temperature, which all geothermal systems are by default, you have a low temperature water delivery temperature, and you don't account for that in your design process, then you're going to rely on the backup heat, which in many cases is electric resistance. And for contractors that do geothermal who don't explain that to their homeowners and ask them, what percentage of the heat would you like to be geothermal and what percentage are you comfortable with being the backup heat source? We found that a lot of times people had sticker shock when they got their electric bill during the design days or design months of winter, because their systems were not able to keep up without the backup heat. So it's critical that the installer has the knowledge, or the designer for that matter, both of them have to have the knowledge on how to properly design and implement a low temperature system to achieve the comfort level that the people desire.
Dave Holdorf has a great saying about that. He says, a discussion beforehand is an explanation. A discussion afterwards is an excuse.
And an expense.
And an expense. And I think that applies here. Make sure they know going in what we're dealing with.
I think that the heat pumps are perfectly matched for radiant the way that we're talking about it. It's like if you were going to win a three-legged race, if you had an identical twin, they would be a good person to run with. If you're just running at exactly, I don't know if I can do this with my fingers. If you're running at exactly the same speed, both legs on both sides are going the same speed, that's going to be helpful to win that race. I think that hydronics was almost harder in the past when the heat source was a cast iron boiler that was really happy being 180 degrees, but we didn't really want that in the floors. That was almost mechanically harder to do. Where with the heat pump technology, it's really what we're looking for the radiant. And if it's okay operating below 100 degrees Fahrenheit, then great. And that I think is encouraging that in some ways, this is not as big a mechanical ask to try and match these two temperature deliveries.
Well, and the lower water temperatures means higher COPs. So, the higher the energy efficiency of the ground source heat pump, the lower the operating cost.
I got a question. I went to Ish for the first time the last time. I'd never been, and I was going there expecting to see boiler heaven, like it used to be. And you had to search to find a boiler. Everybody had air to water heat pumps, and all of them had R290, which meant they could get water temperatures up to 160. Does that's a question I have. Does that change the COP equation any? If again, you design around higher water temperatures, that's better in this market anyway for retrofit applications than something can only do 120. But does that affect the COP?
Oh, yeah. Yeah, COPs are always going to go down as the water temperature goes up. Now, the R290 propane refrigerant will get you to higher temperatures, but the cost, so to speak, of getting there is lower COPs. CO2 is another refrigerant that actually gets you up. We know some people that are actually running 180-degree water with those. COPs are not great. One of the things we have found that right now, the air-to-water market, obviously refrigerant regulations are changing rapidly, and R410A is on its way out already.
Mm-hmm.
So you're seeing heat pump manufacturers moving to R32 is one common one. There's another one called R454B. Those will get you in the 140-degree range, but excuse me, using outdoor reset control on your distribution system. We've been doing some simulations, doing some work with NYSERDA, and we're actually finding that you can get upwards of 85, 90% of the seasonal space heating energy, even from a baseboard system that at design load needs 180-degree water, because most of your heating hours are in those partial load conditions. You don't need 180-degree water when it's 40 degrees outside. You know, your baseboard might operate at 115, 120, well within the performance envelope of the heat pump. So, you know, I would tell people, don't give up on potential use of either a geothermal water-to-water or near-to-water heat pump just because you have baseboard in your system. You're going to have to supplement it under very cold conditions, but still you can get the majority of your energy through the heat pump on those kind of situations.
You take that into account as well. When was the last time you walked into a house that was heated with baseboard that was under radiated? Yeah. And how many feet of outside wall do we have? Put in that much baseboard. Let's get the hell out of here. That's
Greg Gibbs at Shamrock Sales is one of my mentors, and he said they used to sell a lot of baseboard. If we could have put a hinge on it so it would open and close with the door, we would have done that just to go all the way around the room. We were talking about Back to the Future earlier. If I could take the time machine into the future and figure out what the refrigerant of the next 20 years would be, that would be like, I wouldn't go to like the sports book or whatever. I would figure out what the refrigerant is and come back and start manufacturing that if I could, because there's a lot of moving parts associated with that. And some of those are engineering conversations and some of them are political conversations that we'll never understand. The good news is I don't really care for hydronics. We're going to be great with anything that warms water. So any of the refrigerants that we've talked about, whatever is most popular in the future, as long as it makes warm water that we can spin around a house, we're going to be in good shape to deliver on everything that we've talked about for efficiency and comfort. So somebody else can fight over that. We'll do a good job with the water once you warm it and give it to us, I guess.
Yeah. I never pictured you as a Biff Tannen type, Max. I got to say
that's not the energy that I give off.
No, it's not. No, definitely not.
So regulations always tend to drive adoption of high efficient equipment in this industry, and the new Department of Energy regulations on residential circulator pumps are set to take effect in the next couple of years, I think 2028. Yep. John, can you kind of address how those regulations will impact available circulators and how those products will fit into high efficiency, low temperature radiant systems?
Well, they're going to have to fit into everything because as of May of 2020, that's the only choice you have. The Department of Energy has been working on this for years. 2015, 2016, they had the rule written back then, but it got tabled. 2020, we had the commercial circulator energy efficiency regulations that went in. And then we've been waiting to see when it was going to come in for the smaller residential circulators. And that announcement came in April. And we were thinking maybe they weren't going to do it for a while there, but they made the announcement in April and they gave the industry a 4-year implementation period. There had been discussions, should it just be 2? Could it be 3? 4 years gives all the manufacturers plenty of time to turn over their production because all the manufacturers have been so invested in making what they've always been making, and we've been, at TACO, we've been transitioning over the past 8 to 10 years into making ECM products, but now we've got a 4-year definitive window. So by the end of May 2028, if you love AC circulators, if you're a 007 guy and ride or die with the 007, you're going to die because it's going to be gone. As of that date, we will no longer be able to make standard efficiency circulators. We can't sell them, we can't take orders for them, and we can't have them in the building. All right. Now, wholesalers and reps, they can stock up all they want. Okay. Buy as many as they want between now and then, hoard them and sell them until they run out. And that's fine. There's nothing to do with no regulations about that. It's just that eventually they're going to run out. And that's part of the process to transition this rather large market into a more efficient product.
One of the challenges that's going to happen as that transition over to ECM takes place, there are thousands of systems out there that are using what I'll call standard efficiency, a permanent split capacitor motor circulator as an injection circulator with a variable speed controller that counts on the motor technology. It basically reshapes the AC waveform that's going into the motor. Once those circulators are no longer available, eventually those systems are going to need an ECM replacement that will have a controller that can drive it. And it's one of the things I've been trying to push into the industry is that we need potential replacements for injection circulators because of the motor technology change.
Right. Yeah. And the control is going to go by the wayside for those as well. Because again, they can't communicate.
The control will probably be built right into the circulator.
It's going to have to be. So there's a lot of rewiring that'll have to be done when and if those circulators.
What about the ECM circulators that have fixed speeds that we can set? Wouldn't they be a good substitute?
Well, if it's a variable speed injection system, Dave, it's going to have to vary its speed based on what the water temperature requirement is.
Okay. I got you. Yeah.
It could be a 0 to 10 input, or it could be a control that's integrated right into the circulator itself. That I think is the likely scenario.
Yeah, I think I could see the 0 to 10 input because that has multiple applications beyond just that one limited one. I mean, there's a lot of them out there, but the 0 to 10 control strategy can be applied to a lot of different applications. So I would venture to guess that might be where it all goes.
Yeah, I was thinking more in terms of we did a lot of injection systems back when we had boilers that did not modulate. Like Max said earlier, that were, 160, 180, and we came in and installed some radiant and used an injection loop to be able to supply the radiant manifold, which would basically squirt a little bit of hot water in until it was up to whatever temperature we set it for.
Yeah, I'm going to miss doing not being able to do the injection mixing dance. That's been one of the highlights of my teaching career.
I'd like to see that.
No, you would not. Not at my age. No, you would not.
The conversation with ECM though is interesting. Like you said before, Dave, that you put one in your house and you had comfort benefits. Yeah. So I don't think when we first were selling, I worked at a wholesaler, Able Distributors for a while. When we first got ECM pumps, I'd go up to the counter and be like, you guys, you're not going to believe this. The energy efficiency is incredible. This is so much different. They're like, yeah, all right. Like it seems like it's a little bit more expensive. I don't know that I'm the most like energy efficiency motivated. And then at one point I was like, well, and there's some applications where if you closed a bunch of zone valves, you're not going to have too much pressure. It's going to slow down, and like kind of went through some sort of case that would resolve a water hammer issue. And they're like, oh, okay, I'm listening now. Like there's actual comfort benefits to this, and that's true. So that's a fun thing about ECM is one, it's been around for enough time. This isn't some pie in the sky technology that like, no, it works. We know how to do it. We have to make sure it doesn't fill up with magnetite in an old system. There are some precautions that we can take, but the ECM technology is another fun thing like Radiant, that the energy efficiency and the comfort benefits are there. So it's a good fit.
I'd say 25 years of field experience. It's not experimental anymore. No. You're right, Max. You're right. Yeah, it is interesting. I mean, we sell a ton of ECM circulators and a ton of AC circulators, and there's like I said, the ride or die 007 guys that and they're in states that actually have at the counter rebates for ECM that makes the ECM circulator less expensive than the AC, and they say, screw it, I'm still going with what I know. I don't want any of this experimental stuff. And that's just the way the market is. And that's not going to change until it's forced. I mean, we saw every time there's been an efficiency regulation, whether it's 1.6 gallon flush toilets, whether it's insulation on water heaters, whether it's SEER requirements for condensing units or whatever. I mean, it applies. It's the same process every single time. People who are, forward thinking and see the benefits will adopt that technology ahead of time. There's always that segment that says, I'm going to go with what I got till I can't get it anymore. And that's that. And that's the way of the world.
And then we don't miss the leaded gasoline,
Right. There you go.
Once we make the change, there are very few. It happens sometimes, I guess, but this isn't new. So we know what we're getting into here, and we can make these systems run well.
I'll tell you the one thing that personally I've learned over the years with ECM technology is how there's comfort issues, but we talk about in our webinars all the time is that we've really learned about the scourge of overpumping and how that impacts everything in a system, whether it's the boiler efficiency, system comfort, the lifespan of moving parts. I mean, we've been overpumping for so long, and there's been, nobody's really cared. Now that we don't have to overpump, and we can, if we know what we're doing with these things, set them up so that they work in their most effective manner, then we're in a much better place. All the way around, but most importantly in terms of overall system efficiency. And that's kind of the cool thing about it. And it's, I'd say that they're not magic, but they are obedient. They'll do what you tell them to do.
So moving on to the next question, how do zoning controls improve the efficiency and comfort of a radiant heating system?
That's just controlling the comfort where you want it. I mean, it doesn't even have to be a low temperature system. It's just kind of the way it is. There are folks that with a radiant system, I've always found more zones, the better in terms of comfort. There's other issues that are created by that. There's always unintended consequences. But if you've got three rooms that you want to put on one zone, and this room has tile, this room has carpet, and this room has hardwood, where the hell are you going to put the thermostat? There's no right answer. No matter where you put it, you're wrong for two of the three rooms. So in those cases, they need to be zoned separately. Bathrooms should be zoned separately. You want to keep a bathroom nice and cozy when you're wet and naked, just to keep that's the whole point behind having radiant in a bathroom. So zoning is a comfort thing, but you've got to be cognizant of all the other stuff that goes with it. In terms of short cycling, little zones, micro zones can create all kinds of problems.
I'm reminded of when we were at Wiesmann, Dan Hollihan was standing next to me. And I think it was Harold Prell with Wiesmann was saying that every single panel radiator had to have its own thermostatic radiator valve. And they used constant circulation. And as the valves would open and close, of course, they would heat the rooms that they were in. So Dan nudges me and he says, "Ask Harold, how comes you have to have one on every radiator?" And I'm thinking to myself, well, I think I know the answer to this, but so I'm being a stupid idiot. I put my hand up, and Dan, of course, is standing behind me. And I said, how comes how comes it's mandated that you have to have one on every panel radiator? And so Harold looks at me like, you have to be the stupidest person in this room. And he said, like he's explaining this to a 3-year-old child. The sun comes up over here, and it comes up, and it goes over the building. And as it does, these rooms on this side are too warm and these rooms on this side are too cold. But as the sun goes by, these rooms are now too cold and these rooms are too warm. He said, so now do you understand why we have a different thermostatic radiator on every panel radiator? And Dan is he's rolling on the floor laughing.
Did he call you Goldilocks? That's the question.
I don't remember.
How we do this, it makes him just right.
And I think if you ask 100 people what their perfect indoor environmental quality situation is and factored in everything that you can imagine, you would get 100 slightly different answers. And that's one of my favorite things about like ASHRAE standard 55. They're not going to tell you what comfort is. They can tell you a higher probability of what discomfort might look like, because that's as far as we can really narrow it down, because there's not a single answer for everybody. So zoning at least gives you the ability to tailor it to whoever's in that office that year, if you've got zones per room, instead of assuming that everybody is the same, because you're going to miss for most people if there's just one thermostat per floor or per house or something.
The Bell and Gossett Design Handbook I have from 1940 something or other, it might have been 1946, 1948, defined comfort about as well as I've heard it defined. And it said, and I'm going to recall this from memory, comfort is not a matter of supplying heat to the body, but rather controlling the rate and manner in which heat is lost from the body. Just because we make more heat than we need, right? We got to get rid of it. Let's just make sure we get rid of it properly and comfortably, and then we're in a much better position.
Well, and again, you save money. Suppose the kids go off to college, you close the doors to their rooms, turn their thermostats down. And now, if you're keeping the room at 50 degrees, or if you want them to go off to college or want them to move out,
Turn it up. Yes.
Put a lockbox
Turn it
around
down
that
first,
thermostat and turn it down.
Yeah. We didn't think of that. We just moved to a smaller place. I think that might have been a bit more convenient idea there, Dave.
So what are some common challenges when designing and installing low temperature radiant floor heating systems, and how do you overcome those challenges?
Well, making sure the structure's suitable for the type of installation method you're looking at, or adapting your installation method for the structure. All right. If the house hasn't been framed to handle either weight wise or height wise, 1.5 inch gypsum concrete pour, well, then you can't do that. Right. If it's a second floor bathroom, you're not pouring a 4-inch structural slab. It's just not practical. So you've got to, the first thing you got to do is adapt your installation to the project and pick the best installation method for the project you're looking at. I think that's hurdle number one in my book. And then of course the heat loss is going to dictate what you do after that.
Yeah, it goes back to communication with everybody on the job site, but we've had some fairly unique projects. One was a stone home with 2-foot thick walls, and of course you have the great big recess where the window is, where you could park a whole half of an SUV. But people that wanted radiant sometimes couldn't have it because you would find that the delivery water temperature had to be well above 220 degrees in order to meet the, to offset the heat loss. And that's including if you use the walls and the ceilings. We had one that was a stone home that I ended up with 87-degree water temperature because of how well the guy insulated the framed walls on the inside of the stone walls. And he sealed the whole place up. The other thing is, by properly designing, you can obtain the same water temperature, usually within 10 degrees between various rooms. And going back to, I think, John, you mentioned the issue of one's ceramic tile, one's hardwood, and one's carpeted. If you know that going in as a designer installer, you can compensate for that by spacing the tubing differently so that you end up with different BTU outputs per square foot. And you can even that out over those three rooms to a point where you could actually use a single thermostat. But I think going back to John's point, if you put 3 thermostats in those 3 different rooms, you're not going to have a problem. You're going to be absolutely 100% successful and not have any complaints.
Yeah, you'll have to still worry about response time on the 3 different floor finishes, though. That's the one drawback.
Unless you get low enough temperature and you go to constant circ, and then you're always kind of meeting the outdoor conditions as they change.
Well, la-di-da.
The other thing to look for too in existing buildings is get an energy audit, get a blower door test, and see. I mean, as much as the group of us love to talk about the mechanical systems, the best money spent might be blowing some insulation into the attic because it's all settled. Like, improve the envelope and set yourself up for success with a lower temperature system. Make an insulation contractor friend and start there.
I think Nate Adams said it very well. He says, envelope first, equipment second. You'll always be better off.
Yeah.
As an equipment seller, I think he's crazy, but he's right. He is correct.
So moving along to what every, homeowner wants to know, what are the initial costs versus long-term savings of low temperature radiant heating systems?
The math to me was never pretty. I mean, you want it because you want it. I mean, if it's purely a financial decision, I think we're not asking the right questions. It's comfort, it's performance, it is you're getting comfort, and it's going to cost you more to install, less to run. You want to do that math, go ahead. But it's to me, it's a comfort question first and foremost.
Yeah, I'll go back to something that kind of ties together what we've been talking about. I use the term long-term value proposition, and Max made the point, as refrigerant regulations change, we really don't care as long as we have something that can produce warm water. The hydronic distribution system is going to last for decades. If you go with a ductless mini split system, you might be okay, depending on are there going to be continuous drop-in replacements for R410A or wherever that refrigerant path goes. But with water, at least you are probably going to spend a little more money up front, probably, not a lot more, but you're building a system that is adaptable long-term. So there's definitely a value proposition in that something like a VRF system or ductless mini split really doesn't give you that assurance.
And we always had at Worsbo, we would have the question of, well, what about air conditioning? I'd have to have two systems. Two systems are bad. Not bad. It's just two, you have two components, right? And the thing about an air, you got the best, most convenient, most efficient cooling component, the best, most convenient, most efficient, most comfortable heating component, one system, two components. There's nothing wrong with that. And when you start talking about air to water heat pumps or geothermal, well, then we do have one unit that creates both the heated water and the chilled water, and then it takes away it reduces some of the conflict.
We're always doing these return on investment calculations with this like frozen expectation that your utility rates are going to be the same. Does anybody on the call like have the same energy costs that they did 10 years ago?
I live in New Hampshire, man. I don't have the same utility costs I had 5 minutes
yesterday.
ago.
Yeah. So you have to anticipate that the return on investment, if you're talking about today's dollars versus your energy dollar in 5 years, I think that we move a lot in North America. So sometimes it's like, wow, we're not even going to live here at that point. But I think we're staying in place a little bit longer, and utility rates aren't going down. So that changes the equation.
Max, I always used an Excel spreadsheet, and I upsold systems based on what I called ECV, or energy conservation value, which was exactly those costs, but over a 20-year projected period of time, with incremental cost each year going up for the cost of the energy. In the case of electricity, I'd take an ECM circulator versus an induction motor circulator and run that out 20 years to see what kind of cost savings there were. And in many cases, it was more than just a few $100s. So I was able to sell new systems with ECM circulators and steal that work away from my competitors, I guess, if you want to use that word. But I felt more like I had challengers rather than competitors. And part of that was knowing what their products were going to be. I would ask the homeowners, what are they planning to install? I don't want to know their price. I want to know what they're planning to install. And I would never denigrate another contractor, but oh boy, I would go after the equipment. If they were putting in an aluminum block boiler, then I'd say, well, have they talked to you about what has to be done to protect the water over a period of time as far as water treatment is concerned? No one mentioned that. Well, let's look at what's involved, and then the homeowners would invariably say, well, I don't want to have to do that. I say, well, my boiler doesn't do that. It's got stainless steel, and it's going to have a longer lifespan, et cetera, et cetera. Anyhow, all's fair in love and war. So going after the product, but not the individual, was always fair game.
I have to check out, folks. I've got a webinar in 4 minutes, so I've got to go. Nicole, thank you so much for having me. John, good to see you as always. Max, Biff Tannen. Now I got a new nickname for you, man.
Thanks, John. I appreciate it.
And Dave, always a pleasure, man. So
hey,
thank you so much for having me. I appreciate it.
See ya.
Don't talk about me when I'm gone either. I don't want to.
Oh, we will.
Now, another thing about utility rates is, they're increasing rates during their peak hours and peak demand. And I know, John, you've touched on that quite a bit in your columns.
Yeah. You're going to see more of that. Electrification targets that have been set by states or, even at federal, provincial levels. One of the ways the utilities are going to get there is by creating rate structures that encourage consumers to pull energy through the meter, not at peak times. So basically, they want to level out their loads. Hydronics is a perfect media to take advantage of that. And, we could talk about water tanks as storage, and that's possible, but there are other hydronic-based methods, solid materials, things like flowable fill that can be eventually integrated right into building construction, that can be the mass to store that heat, but getting that heat into that mass and getting it out of that mass to some extent, hydronics is a good media to do that. So thermal storage, time of use rates, heat pumps, again, you're seeing kind of a synergy there between all these technologies that come together. And again, what unites them is hydronics.
Now, Dave, as a former contractor, you kind of talked about this a little bit with, talking about possible competitors. How do you separate yourself from other contractors and win bids while not being, the low bidder?
Well, for those of us who are old enough to remember the old TV show Car 54, Where Are You? I kind of feel like Gunther, whenever I get excited about something and I want to talk about it, and I go, oh, 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 which he always did when he wanted to interject something. And so I have to go back to our dear friend Bob Mader, may he rest in peace. But he knew that I could get wound up and go on and on and on about radiant heating. So we were doing a forum at one of the comfort techs, and Bob said, now look, Dave, you'd like to talk a lot about radiant heating, but I want you to make this as concise as you possibly can. And so I thought about it for a minute and I said, all right, here it is, Bob. You ask, they tell, you sell. And it really is that simple. I would sit down with potential clients and ask them a ton of questions. What are your expectations? Where do you have comfort? Where don't you have comfort? Where do you, what temperature do you want? And oftentimes people would say to me, none of the other contractors have asked me any of these questions. And so what that does is it establishes trust. And once you establish trust, then you're no longer a commodity. You're not selling on price alone. And price is still important, but it's at the bottom of the list. It's not at the top of the list. And once you gain that trust, you're in like Flynn. You can upsell jobs. We sold jobs to people that were $20,000, $30,000 higher than the next closest bidder, because the people understood. First of all, we established that we knew what we were talking about. Then we got their confidence. Then we just, we talked about our products and why they're the best products available on the market, and they cost more. You're going to, the difference between a Volkswagen and a Mercedes is pretty obvious. And so once we did that, that's all there was. We could upsell like crazy. I had a tremendous close rate on the jobs especially if I could sit down with the homeowners. Once I could do that and educate them about why we were going to sell them, what we were going to sell them, invariably, more than 85% of the time they went with us.
Okay. Now, what innovations or emerging trends should be considered, when planning new low temperature radiant heating systems, going forward into the next 5-10 years?
Well, I like John Siegenthaler's approach to this, which is, everybody has been emphasizing the operating efficiency side, particularly with fossil fuel appliances. John has long concentrated on the electrical consumption side. And don't ignore that, because it's a huge component for what we're talking about, especially with the electrification of everything. But John, you can pontificate on that.
Well, yeah. I tell people, don't get hung up on the politics. You might agree or you might strongly disagree with where these regulations are going. But one thing I think you can agree on is that if you're involved with designing or installing or selling equipment for hydronic systems, you've got a huge opportunity right now. And, I consider this one of the best times. Dave, you and I have been doing this for 40 years plus. This is really one of the best times to get involved in hydronics, to learn the technology, because it's going to apply. We've talked today about heat pumps. We've talked about low temperature distribution. We've talked about time of use, electrical rates, thermal storage. That all kind of gels around hydronics. And it's a good time to be in the market.
Yeah, it's an incredible time. There's so much opportunity out there for contractors right now. It's phenomenal. And Max, I'm sure you're seeing it.
Yeah, and I think that the machine that we can build today is great. I think that there are a lot of different places in the energy efficiency world, outside of heating and cooling, that they're still looking for something to make cars more efficient or whatever. The machine that we can build today is really good. I think that what we can work on in some innovations would be controls, so we can have better response to what occupants are doing. We can kind of predict what's happening with a little bit deeper understanding of the weather that day. If we're about to just get an enormous, 18 inches of snow storm that's going to roll through. Some of those things are different from just the indoor temperature and the outdoor temperature that we can predict a little bit better. So I think that's where there's room for more opportunity there. But yeah, it's inspiring that the hydronic system that we've talked about for our whole careers is really, future proof, but just like sets us up well to make an energy efficiency system with the stuff we could drive down the street to a hydronics wholesaler and purchase today.
Well, that's pretty much all the time we have today. Was there anything else any one of you wanted to add?
I would add that avail yourself of the training that's available. We can talk about John now that he's gone, but TEPCO has wonderful training for contractors. And I always made a point of getting as much training as I could throughout my entire 48-year career. And it paid off in buckets and buckets of money for us and our firm in the long term.
Yeah,
I
great.
agree with that. I'd also say that don't just limit yourself to just hydronics. Watch what's happening with building markets, things like net zero. That's one of the fastest growing segments in the construction industry. And keep asking yourself, how do I keep what I like to do with hydronics? How do I keep it relevant in net zero or other building technology trends?
Yeah, that's one of our mottos was one call does it all. So while we loved hydronics and we specialized in radiant heating in particular, we installed a ton of mini splits, VRF systems. Basically, we wanted all of your plumbing, heating, and air conditioning work, period. And whatever it took to get that is what we would do.
Max, did you have any closing thoughts?
I was going to say the hydronics trade is just such a great one. There's so many different jobs in the design and install and manufacturing and training world that it just, I've had the cool fortune to have worked in worn a few of those different hats and have loved every one of them. And I think that this is just an amazing career path and something that will pay dividends because it's just going to get more and more important as energy costs go up.
Okay. Well, thank you all again for taking time today to join us. We really do appreciate it. And I hope you guys have a great rest of your day.
Thanks,
Nicole.